Good morning, one and all present here. I would welcome you all for the webinar series organized by the Department of Electronics and Communication Engineering on the topic of migration of database Azure. It is being presented by Mr. Satish, Cloud Database Migration Architect. Welcome you, sir. Thank you, sir, for accepting our invitation for the webinar series. I would hand over the session to you, sir. Thank you.
Thank you, Sita Raman, for the quick introduction. Welcome all. It's a privilege to be in front of you to present this, and I hope my session would give you an insight on the career path to cloud database migrations when you complete your graduation or you are part of the final year and looking for career opportunities. So this is a good area to look at. I spent last 20 years in this field of data migrations and data modeling and data architecture. So I'll walk you through. I have based my session on this topic with some basic, and then I'll be taking you through the journey of migrations, the challenges we encounter as an organization in Accenture for our Fortune 500 clients. So here we go. First would be introduction to cloud. Most students would have got a general idea about cloud in the college courses or G.N.N courses where they are attending and understanding about cloud or the YouTube videos. But I still want to go through this before I embark on the DB migration. So if you look at this, you have what triggers the cloud migration, right? Why do companies go for cloud? And what are the benefits of going to cloud? In Accenture or in services companies where we do cloud migrations like CTS, Infosys, Accenture, and even Microsoft, Amazon have their own consulting practice around cloud migration. We call it journey to cloud. If you see this word coined here, it's called J2C, a short way of saying journey to cloud. And the common triggers we have for clients, they have databases, their applications in an infrastructure, which is a data center. If you have looked at your college lab and if your college has got a good computer science department, you would see a stack of blade servers aligned on top of each other, right? Each blade looks like a DVD player. If you come from a generation where you have played the DVD player, it will look familiar. It will look familiar like that, but it's black in color and the casings are silver and it's stacked around 8 to 10 feet above, right? So most migrations we have seen is because they have an infrastructure which is 10 to 15 years old, and they want to move to cloud where the best practices of security, compute power, and savings can be visualized by businesses like telecom majors like AT&T in US or health pharmaceutical companies, right? And the second major reason we have seen is end of product life cycle. Like every technology they use in the database world, like Oracle, if they are in Oracle 11G, the database support would have ended. So they would be looking at upgrading to Oracle 12C or the latest Oracle databases in the cloud, which is a PaaS service, right? So when they go through that journey, they would like to go for public cloud, or they would go for a private cloud, or they would keep a hybrid cloud. When I say hybrid cloud, what I mean is they'll have some environment in their on-premise, in their LAN, and some on the public cloud, which is called a hybrid model. And last, if they have been using an application for last 15 years or 20 years, and they want to go to new application stack, like Azure Functions or app services in the cloud, they need to recode their platform, right? They need to recode their .NET code into the latest version. So that part comes under modernization. So when we say modernization from the database world where I come in, when I say modernization, I mean I may move it to a new platform. I may change the data model. I may, when I say I change the data model, I may denormalize the existing transactional system further, or I may build a new analytical platform on the cloud. So these are the triggers, three main triggers if you see for cloud migrations. Moving on, what are the benefits? Why do clients prefer cloud, right? If you look at the wordings here, you would see ACE, the word ACE, and A stands for automation. Yes, cloud is highly automated in terms of deployment. Um, you have DevOps pipelines to run your codes, provision your infrastructure, or provision a virtual machine in the cloud along with the database technology within the virtual machine, or you can provision your PaaS services, right? Uh, and when I say PaaS, it's platform as a service where you cannot log into your virtual machine. You get that cloud service as a feature, like you have MySQL PaaS or PostgreSQL PaaS, or SQL Server, which has got two or three flavors of PaaS technologies, right? And then of course you have compute power. Why do what do I mean by compute power? Even today's handheld devices have a lot of compute power. Your iPhone or your Redmi phone, which you use, has got good compute power than the days when we began our career, right? But the advantage of compute in the cloud is you can scale up the service. You can scale up from 12 GB RAM to 15 GB RAM, or you can increase your CPU just as you move the slide bar in the screen, right? So it's much easier to scale in the cloud. So that's one of the reasons why clients prefer the scalability option with the compute power they get in the cloud. And the third main, the bottom line for any business is the savings they achieve. The word economizing is a recent word coined by Oxford. So I use that terminology here. But practically, it means saving when you go to cloud. And usually, the rate of returns after you invest on cloud infrastructure, you move your applications to the cloud. It could be the retail stores you're moving, or it could be as simple as Shell moving its analytical platform, the Shell, the petrol company, moving its loyalty prep applications to the cloud and achieve savings in the next 3 years, right? They do not have to maintain a data center which requires cooling technology. You don't have to pay for the space you are provisioning for your data center because you're not owning that anymore, right? And and you don't have to do patch management for your operating systems and your databases, right? So all that effort of maintaining the infrastructure, the platform, the software, all goes away with cloud. And the last 5 years, we are seeing large scale migrations to the cloud for most of the clients we are working for here. Who are the three major cloud players? I know most students are aware of this, but I thought of putting it across here. You have Amazon Web Services or Amazon, which is the oldest cloud provider. Somewhere around 2006 or 2007, they started giving um, cloud services. Then Azure came up in 2011, and GCP at a similar time frame. As a data architect, I solution on all these three platforms, right? And depending on the technology and the requirement, I would choose GCP over Azure, and or AWS over Azure. And GCP is well known for the TensorFlow machine learning algorithms they use. They're much matured models for machine learning. And Azure, I would target for application services, non-SAP or non-ERP applications. Even SAPs are going to Azure, but it's more of a transactional world. Yes, they have good OLAP system. My favorite is Azure, so I will be biased to Azure. I'm telling you upfront. So Azure has got niche services now, 300 plus services Azure has. An advantage of going to Azure is it's available more than 50 regions in the world, whereas AWS and GCP are available in 20 regions in the world. So that makes a huge difference when we have clients from different parts of the world who want to go to Azure. Right? And Azure also has a private cloud, which is called Azure Stack, and for clients who are in the financial domain. AWS also opened its own shop for private cloud, and GCP also has its own flavor. But Azure is dominant in most regions of the world where it has data centers across the world. So that is one thing. And they also have good services on on the analytical platform. They have built an analytical platform around Azure Sparks or Databricks, which is open source. And with Satyam leading Microsoft, with Satya Nadella leading Microsoft, last few years Microsoft has embraced open source, which has given it an edge over GCP and AWS. So I'll stop with the introduction now, and we will move to database migration, which is my favorite topic, and also where I apply myself a lot the last few years. So when you start with database, we have a standard procedure, right? A standard process behind database migration. Whenever a client comes to us and says we need to migrate around 4,000 servers with 400 applications, and how do we go about it? So we show him this overall process journey of moving to the cloud, where we spend, say, if the infrastructure is very large, say around more than 1,000 servers we need to assess, which has got around 200 to 300 applications. We would start with an assessment phase, which usually goes on for 4 to 6 weeks. And during this assessment, we use two tools, right? One, which is a functional tool where we upload the interview process. When we say interview process, I mean the assessment process where we talk to the application owners, talk to them about their architecture, fill in the details of their non-functional requirements, the response time, and all that during the assessment phase. And also we do a technical assessment using tools called Cloud Amaze and Cloud Endura. These are cloud-based tools. There are a lot of third-party tools which help us do assessment, and we do have our own tools in our organization, which is called MyNav and A4C and a couple of other tools which do assessment. They do technical assessment. There's an appliance that is launched into the cloud, and it does the assessment. It will come in later. I'll show you how that architecture looks like. So after assessment, we sit with the client and finalize the migration time frame, and that's where we come in as solution architects, where we estimate the effort of how the dependency of the application to the database, identify the database server inventory, which looks like an Excel file with the version stack of all database technologies. It could be Oracle, it could be MongoDB, it could be SQL Server, it could be DB2, and looking at the technology stack, we create the wave bundles. When we say waves, we mean the time frame in which we will do where we will do the migration. We call it wave one, wave two, and so on, right? And in each wave, we will categorize what applications we are taking in there in terms of architecture. If there's a web application with two servers, one is the web application server and the database server, then we'll categorize it as simple, and then we will put it in the wave one migration planning, right? And once that is all done, we start with the actual pre-migration activities. In this case, I'm showing you SQL Server. It could be Oracle as well. So we will do the assessment using in SQL Server world, we have Data Migration Assistant, a tool which does the assessment for every database in the SQL service, and it gives us the compatibility and suitability for Azure SQL PaaS or IaaS, right? And then we would also go ahead and provision the recommendation given by the tool with that service tier of SQL Server in the cloud. The target systems will be made ready, and then we would start initiating the sync process through the mirroring or replication technology, or even the data migration service, depending on the downtime requirement we have given by the client, which we capture during the assessment and the mapping phase. Yeah. And then after we move the lower environments. When I say lower environments, we have development, test, UAT, that is user acceptance test systems, and then the production system. So we move gradually from the development to the test environment to the UAT environment to the production environment. So we do migration on a lower environment, and then do the performance testing of the application, whether it's performing at par with their on-premise environment. So the migration from on-premise to cloud has to meet the benchmark of the response time. Say you submit an order in a retail website like Amazon, and you would expect the order to be processed within a few milliseconds. So are we meeting those benchmarks after we migrate to cloud? So those kind of testing happen in UAT environment. And finally, if we meet those benchmarks, then we get a sign off by the application team or the client team. So this is the entire business flow of the migration process. And on the left side, on the last left side, you have all the tools we go ahead and use. We use PowerShell, we use Terraform scripts for provisioning. Terraforms are like JSON scripts for provisioning the environment, and also we use a client configuration management database. The configuration management database for the client is nothing but a software where it will store all the information of their landscape. When I say landscape or the estate, I mean what they have, like what is the name of the server, the IP address of the server, what application uses it, and what are the technology deployed in the server. So that is called a configuration management database. So if they have a up-to-date configuration management database, we may skip the assessment, and we may rely on the CMDB to get the inventory for the planning of the migration of all large scale application migration and database migrations. Okay, so this is about the overview of the migration process, and I will move to what are the migration types we have in the database world. Right, we have three terminologies. If you look at this, the first is called a rehost, and which means we practically move the database and the operating system as is, which means if you have a Windows platform or a Linux platform, a Ubuntu version on which you're running Oracle 11.4.6 or 12c, or if you have a Windows operating system with 2016 and you're running SQL 2017, we move that version, the platform, the operating system platform. We don't upgrade, we just move it as is. There's no upgrade involved. We maintain the data model structure. If you have studied DBMS, computer science students usually would have studied data management systems, and in that they would have come across data modeling, what is normalization in voice code, right? So all that data model doesn't change when it goes to the cloud, from on-premise environment to the cloud. So that's called a rehost, or also we call it as is migration or like to like migration. And the second migration is upgrade or replatform. Here we consider end of product lifecycle. Like in the first deck where I showed you what are the triggers for migration, we were talking about end of product lifecycle here, right? So that comes into picture here when we strategize it for upgrade. So we may move from legacy version of Oracle or SQL Server to a higher version or the latest version of SQL Server or Oracle in Azure or AWS or Google Cloud, right? And we call that replatform also. We may even move it to the platform as a service model where you don't have a virtual machine to connect to, but you have a service to connect to, and it's much more investor friendly for the client. And the last option or the type is the modernization, where we may consider heterogeneous migrations, where we may move databases from Oracle to SQL Server or Oracle to Azure Synapse, which is a parallel data warehouse, right? Um, so modernization involves even change in data model and also change in technology platform from a different software vendor, right, in the cloud. So this is the most complex of all migrations, which is modernization. The first two options are relatively simple. The first one, which is called rehost, is simple, comes under a simple category of migration. It takes lesser time for us. An upgrade and replatform has its own effort. It comes under medium category of migration in terms of complexity, and modernization comes under the complex form of migration. So these are the types of migration which we do. I purposely underlined the first few words. So if you go back and you recollect this slide, you will remember the word RAM. so so you would remember it as rehost, upgrade, and modernize, and and you would remember the migration types we go through. What are the migration patterns of various database stack in Azure? That's what is covered on this deck. So if you look at SQL Server in Azure, it can go to SQL Server virtual machine. The migration can be done to the data migration service, which can perform online and offline migration. When I say online, the on-premise environment, or say your college lab is an on-premise environment, and you plan to host all your educational videos on the cloud, right? You subscribe to an Azure subscription, and you set up a virtual machine in the cloud where you'll deploy your .NET education platform and your SQL server there, right? Which will be the backend for your education service program for your departments. So when you need to migrate here, you can do online migration. So this service on your on-premise or your lab or your data center in your office or your server in your office will be online when the actual migration happens. And if everything is good in the cloud, finally the cutover happens. When I say cutover, there will be no connection to the on-premise, and all the traffic will be routed to the SQL server or your application in the cloud, right? And then you have your Azure database services, which are managed instance, and then you have a single database model. These are PaaS services, platform as a service, right? How it looks like is, let me flip. I hope you guys can see my screen. So when I click on Azure SQL in Azure, I'm in the Azure portal. This is my test subscription. Let me see whether I can create an Azure SQL here. So when I click on Azure SQL, I get three options for the SQL platform, SQL database platform. I have one which is called a single database, which has got hyperscale and serverless option. I have SQL managed instance, and I have SQL running on virtual machines. When you select SQL virtual machine, which is also called infrastructure as a service, right? Here you get an option to choose the version of SQL Server on which Windows platform. So you can have developer edition with on Windows 2019, and you can create it. When you hit create, you'll get various options, right? You can create a virtual machine in matter of minutes. That's an advantage of provisioning in cloud. What I'm doing now is called what you say is called provisioning manually through the Azure portal. I go to portal.azure.com and do it. But there is a way to do it in an automated way using Terraform or ARMS template, which we have in Azure. So when you do next, you can select the size of your virtual machine. If you go here, you get an option to select the size, and it also tells you the cost of that size per month. So these are the costs. This is the and these are the data disks associated with that virtual machine. And what is a tire, what is a service tire? This is the general purpose tire. And what are the vCPU or the processing power you get in the cloud? What is the memory you get? What are the disk you get? And the cost associated with it. And usually for less critical systems, we go for DSV2 series, which is here, and we select that option, and we take one of these memory optimized family of servers, right? So this is one way of provisioning. Going back, and if I go back to home and go back to Azure SQL, go to create again, and that is about virtual machine. With a flick of few minutes, you get a virtual machine with SQL Server pre-installed on it. If you do not want a virtual machine, you don't want to maintain operating system, and you don't want access to operating system, you don't want to pay for operating system licenses, then you can go for SQL managed instance, which is a platform as a service model, right? And you can create this as well from the Azure portal. This feature of creating from the portal is same in AWS and also in Google Cloud. So, but in where Microsoft or Azure beats AWS or GCP's, its user-friendly interfaces. This UI, which is very user-friendly, can be used, and and you can create a managed instance. A managed instance takes a longer time than a virtual machine because it takes around 4 hours. Internally, it has to provision in that region and give you the service, build some firewalls and security around it, a virtual network around it. So this takes around 4 hours to 2 hours minimum to create one. And then you have this single Azure SQL, single databases for where you're going to have complete, it's a full-fledged platform as a service and closer to software as a service model. But it's not called software as a service yet because it doesn't have an application layer, right? So here you get single database where you can host one database in one service tier, and then you have elastic pool for erratic workloads like applications which do seasonal sales or weekend sales, like you have your big bazaar, right? The big bazaar or more supermarkets, they will have seasonal sales on, or weekday sales on Wednesday. The load will be higher, so you must choose elastic pool, and you get you can it works on the compute power, right? So if you are utilizing CPU for 2%, it will charge that much. If your CPU utilization on a seasonal day or on an offer day on Wednesday, the traffic is more, the transactions are more to the database, it will increase the CPU accordingly, and it happens live. So the users of the application will not feel the difference, and it will give you the same power. And then you have a database server, which is kind of a hyperscale model for 100 TBs or more. Okay. So these are the three flavors of SQL Server in Azure, which is SQL Virtual Machine, and then you have this managed instance. Managed instance is also called remote relational database service in AWS and GCP. In GCP, they call it as Cloud SQL, which is equal to SQL managed instance, but they do not have this pure form of platform as a service which Azure has, or SQL platform, right? So these are the three flavors of SQL Server in Azure. And coming back to the deck, let me go back here. So if you see these services I showed you in the portal, so these are the three flavors you have in the cloud for SQL Server. For Oracle in Azure, they have only Oracle Virtual Machine. That is, you have a Linux server and you have an Oracle deployment software on a virtual machine in the cloud. If you choose Oracle public cloud, you will get Oracle as a PaaS service. But in Azure, Oracle has not given them licenses to run a PaaS service because it's a different company altogether, right? And then you have MySQL, an open source database which can run on a virtual machine and also as a PaaS service as Azure database for MySQL. And you also have PostgreSQL, a very good open source database and high performing database like SQL Server and Oracle, which can run as platform as a service. Also, DB2 has got virtual machines. You have other databases like DB2, which will run virtual machines. And if you have MongoDB, which is a document database, it can go to Cosmos DB, which is a PaaS service. It's globally distributed. It can hold document databases and other data models as well. Also, you can host MongoDB on a virtual machine on a Linux box in the cloud. You have two options there. And the third option being a PaaS service from Mongo Atlas vendor himself, who has got a service in Azure, AWS, and GCP. So depending on the technology stack, you get the flavors of infrastructure as a service, which is like the database running on a virtual machine, or you will get platform as a service where you do not get to get into the operating system level, nor you need Linux or Windows administrators to manage those platforms. So these are the migration patterns, and we will move to the first migration, right? The types of migration I talked about in rehost, right? Where we do like to like migration. The easiest way of migrating to Azure is using this free software called Azure Migrate. So in the on-premise or in the data center, which is locally hosted, say in your case, it's your college environment where they have a server A within the college LAN. We will install a software which is called an appliance of Azure Migrate, a software, and it will go ahead and connect to the VMsphere or vCenter, which is nothing but a virtualized administrative console for all virtualized environment in your on-premise world, right? So if you are using VMware technology for virtualization in your environment, in your on-premise environment, it will go to that administrative control and do the assessment It will map all the application servers and the database server and push that data, the raw metadata, to the server discovery service, which is there in the Azure cloud, which is a SaaS service. And then it will start doing the discovery. It will ping these servers in these ports 443, and it will also use HTTP ports and these V ports, and it will connect to these to the service, which will do the assessment and also will tell you what service there in the cloud will match your application requirement. And it takes 2 to 3 weeks, and this appliance has to be run during off-peak hours of your business. Usually, we run it during off-peak hours. So when I say off-peak hours, when say your big bazaar market opens from 9 a.m. to 10 p.m. So all the POS systems where they go and do the billing closes after the last customer leaves at 9 p.m. or 10 p.m. Then from 10 p.m. to morning 10 a.m. or 8 a.m. is the time which is called the off business hours. That is when we will run these assessment tools to gather the understanding of how many servers we are going to migrate, what is their compute power, that is, what is the processing, the memory, and the disk space they are utilizing, and what is the equivalent of that technology in Azure. So this takes around 3 to 4 weeks for the assessment to complete and then the review to happen. And after we do the assessment, we can even do a VM level lift and shift. When we say VM level, the virtualized VM, which is running on the data center, we can migrate that VM directly to the cloud. So we call it lift and shift. It is like moving your house with a bulldozer to another place, right? So it's much similar to that. Or you can imagine it as moving a container from the ship to the dock. So you move a huge container from the ship using the crane and you move it to the dock, right? The ship is your on-premise, and say your container or your dock, the shipyard is your Azure platform. So we just lift the container and put it over there. So we lift the whole storage, we lift the operating system, the virtualized environment, which is nothing but uh, uh, nothing but a file system, right? Under the hood, a VMXDX file would be there, a flat file which holds all this information, and we replicate it to the cloud. So it's an online replication, and you can cut over it on a weekend as well. So you start the replication on a weekday, and then you cut it over on a weekend. So this is called VM level migration or lift and shift of migration, where we don't do at the database level, we do it at the operating system level. We also can migrate physical servers to the cloud to a virtual machine now in Azure. That capability came last year. Earlier, we did not have that option. So even if you don't have a VMware, you have a physical server A class machine, which is around 3 feet tall, right? In your lab, we can take the operating system snapshot. We call it operating system or volume shadow copy snapshot, and then move it to the cloud and uh, and bring up that snapshot in the cloud with all the data and all. Yes, for doing database migration, we usually shut down the database service, because if you don't shut down the database service, the consistency of the data wouldn't be there. So every RDBMS technology, if you have read in your computer science book, will follow asset compliance. And one of the asset compliance is durability and consistency of the data. To achieve that, we usually shut down the SQL, Oracle, or MySQL or Mongo services before we do VM level migration. And then once the operating system and the storage, the data is migrated, we bring the virtual machine on in the cloud. Uh, we will start the service there. So you can imagine, I'll take you back to the portal where I will take you to my home page, where I have already provisioned a virtual machine, right? So currently this virtual machine, right, when we migrate, this virtual machine will be in syncing phase and it will not be stopped. So in the cloud world, right, you can stop the virtual machine and you can restart the machine from the portal itself. So if you have a development and a test environment, you can just stop the test environment during the weekend when developers are not there. Or if your developers are in India and they work India hours, after they leave, you can schedule it to stop. So there is cost saving also associated when you are using a virtual machine service, right? You are using the operating system. You pay for the storage alone when the service is stopped. So that benefits are also there in the cloud, and you can connect from your laptops using the connection string which is given to you through an RDB session uh, and connect to the virtual machine in the cloud. And you need to ensure that you have the ports open for the cloud, right? So this is the public or the private IP address, and the public IP address also is given. Usually, we will not show the public IP address. We will keep it under a private link for security reasons, and you will connect through a private link to the cloud services. So, so coming back here, so after you do, so the rehost option is the simplest way of migrating SQL databases or application servers to the cloud using Azure Migrate. There are also other third-party tools like Double Take and Move. These are third-party tools which do these kind of migrations also. They have much higher data volumes they can do. And then second is rehost or upgrade, right? You can move your database backup. You can take a database backup, move it to a cloud storage, and restore the database backup. This is called DB level migration. This is more complex than a VM level migration because you would need to automate through scripts to do this, and it has got many components, right? And we primarily use this migration approach across the environment when we want to move, say, from SQL 2000 to 2005 or uh, 2005, or we want to move from SQL 2012 to 2016. So we will take a backup of the older version and restore it in the current version, and then do it. But even before we do it, we go ahead and do an assessment of the database using data migration assistant tool or other tools. In AWS, we use the schema conversion tool to do the assessment, which is similar to data migration assistant in Azure, and then migrate the database. This is at the DB level where we take a database backup. When I say database backup, it's a native backup. And we want to see that. Let me quickly bring uh, show you how we do it in SQL Server. I don't have an Oracle installed on my laptop, so I'll be showing you SQL Server, which is much lighter on my laptop. So it's coming up. Takes time to come up. So I use this GUI tool, which connects to a SQL Server database engine. So it's just popping up. The version is 18.5, and it was last released in last year, 2020. So let me see whether I can give you a quick demo of how we take a backup, how the database administrators take a system level backup and then restore it in the cloud. So it's taking its own sweet time. So this, while that comes up, let me come back to the current slide. And so when we do this database backup, we take a full backup. In the RDBMS mode, you will have full backup and incremental backups. Okay. So depending on if it is a weekend cutover or you are going to migrate during the weekend on Saturday or Sunday, then we take a full backup. We bring the application server down so that there is no connection against the database. We take a full backup, move it to the blob storage, Azure blob storage, or in case of AWS, it will be an S3 blob storage. And from the blob storage, we restore it on the virtual machine in the cloud. Or we may attach this blob storage as a network file share to this virtual machine, and we can restore that backup to the target SQL server in the Azure platform. Yeah. So let's see whether the tool has come up. Yes. So I'm connecting to my local laptop. Imagine my laptop as an on-premise system. I connect with my domain account. So if you see when I connect, you would see my name there and my domain account here, and I can go ahead and take a backup. The easiest way of backup in SQL Server is through GUI, but since I'm an experienced database administrator, I prefer using scripts. So I'll say backup database, and I'll give the database name. Windows Works 2016. Yes. uh, test, you have the file name, and I will say compression. I can apply compression to the backup. Want to look at the status of the backup. Just see. I'm taking backup. I'm not taking incremental backup here, and I will say F5, and I can see the backup proceeding. So when the backup completes, it will create a file in that location, and it will take a backup of the data and the log file of SQL of the database Adventure Works, and it will place it there. And if I need to restore, I just need to say restore this database, Adventure Works 2016. I'm not giving an example of moving this to cloud. I'm just showing you here, but the steps don't change a lot. Okay, so once I physically copy or use a tool called Azure Easy Copy, I can just restore this backup file here from the backup from disk, and replace. And I can give time, and for temporarily, I can restore it with a new name, Adventure Works 01. I'll create a new data backup. So this is how most DBAs will do. Right now it's giving me error because the path of this MDF file, there's already a file name with this. So it's not allowing me to push it in the same location where I need to restore. So in the interest of time, I'm just showing you this command. So when you restore, you need to move it to that location. We're running short of time, so I can't show you that right now. But if you want to see, you can script this task as restore database, and this itself takes time on a laptop. So I'll go to device, and I'll pick the file. So you see this user somewhere and my name there, and there should be a test backup. I say okay, say okay, and then I change the name of the file. So if I come here, there will be a name change. I can restore this database as 01 instead of the same file because I'm restoring on the same server for test purpose, but usually I'll be restoring it on cloud on a different server altogether. So I just need to give the change of name, and then I can script it out in a new query window and cancel. So if you see, the command changes a bit so that the new file names are introduced. You come here, see the move command coming in and moving it to a to the same location with a different name, right? So now when I restore this as a test database, AW 2.16, then it will go through. Let's see, backup database. I did a backup log there, so I'll do a restore database. So I don't need the first command. So database AW, and I'll restore this database. It will be a new database, copy of the existing database. And when you look at the messages, the restoration is going through at 100% and says it's complete. So this is how I do a system level data migration. So when you do this, you simply use the native tools of that technology. In Oracle, we call it RMAN backup or RMAN restore. And in SQL, we have this backup and restore commands. So we do the system level data migration doing backup, native backups. We can script it, automate it, and do that as well. I have shown you manually. We can put it inside a nice job and automate this whole process. Then we have the rehost plus upgrade, which using rollover migration. This is for complex downtime requirement migration without the data migration services, which I talked about in the migration pattern document. Here we set up an always on availability group, which is a high availability technology like clustering, but a little bit different. We call it distributed always on, where there is a connection from the on premise to the cloud, and we set up a failover cluster. Uh, the failover cluster for these two servers on the on-premise is within this environment of on-premise world, which has its own IP addresses, and this is in the cloud. And then we set up a distributed always-on, which has this mapping of these IP addresses, and then we synchronize at the database level. So if you see, the primary of this on-premise will synchronize with the forwarder system here in the cloud. And once we synchronize, this forwarder will pass it to the secondary system on another region. If you want to set up high availability in the cloud along with the migration strategy, this is one of the complex migrations we do for low downtime requirement, where the application in the on-premise is 24 bar 7 and the downtime is only 15 minutes. Then in those cases, we take this complex strategy of high availability in SQL Server. In SQL Server, we use always on. In Oracle world, we use a third-party software called Golden Gate to do the replication. Uh, in MySQL world, we have a different replication strategy, much similar to this, but it's not called always on. So we have replication technologies. These are called replication technologies, where we replicate at the database level and move the database to the cloud for meeting low downtime requirement. This is complex in configuration and deployment, but nowadays in Azure, you can quickly do it through JSON scripts or JSON scripts with CI/CD pipelines in the cloud. Then one type of modernization I wanted to show you quickly is how we migrate SAP databases of 20 terabytes. The source DB would be in Oracle, and the target DB would be on SQL Server in Azure. So when we migrate the production databases which run the transactional system of SAP supply chain or ERP, that is enterprise resource planning for the manufacturing side, we use another server called R3 Load, which is an SAP tool, which is nothing but an extract loading tool, which is a CLI tool, which will connect to the database and pump and push it out like a flat file. It will create all the 500 or 1,000 tables in the SAP databases which are in Oracle, and create that into flat files or .txt files, which can be loaded by the same system. In this case, I put two host 1 and host 2. Usually we'll have only one host for R3 load in the cloud, which will be on a virtual machine. This R3 load service would run there, SAP tool service would run there, and it will connect to the source DB in on-premise. And it will then push it to the target SQL server. So this tool, which is called R3 load, is basically an extract and load tool provided by SAP to migrate SAP databases. This is why we call this modernization or heterogeneous migration, as we can use this tool to migrate from Oracle to SQL Server or from SQL Server to Oracle. This was specifically developed by SAP to migrate their SAP databases to different platforms. It's been around for more than a decade, and we use it a lot for doing migrations of large databases, which is around more than 10 terabytes. And usually it takes us 15 days to migrate 10 to 20 terabytes or 30 terabytes data using this tool. So with organization, we can do this within a week or 7 days max, 7 to 10 days max, depending on the network traffic we have between the cloud and the on-premise world. So what are the technical challenges we face during migration? The biggest challenge we face in the industry is the volume we are migrating. If it is above 50 terabytes or 1 petabytes, how do we migrate that data quickly and efficiently without losing data, right? So in Azure, Azure launched Azure Gateway, which is a fast networking appliance which has to be installed on the on-premise as a virtual machine, and then it routes traffic over express route, which is a fast internet traffic, which is up till 100 Gbps, and then you can migrate that data. It's an expensive one-time solution for for clients who are having historical data which runs to more than 10 years. Especially these large volumes are related to analytical systems, which are data warehouses, and there we need to use high-end technologies to the migration. Even after using Azure Gateway, sometimes we get network failures because their aging infrastructure doesn't have a network switch on the data center to support that bandwidth. Then we have offline options of using an Azure data box, which is an appliance which is shipped to the physical data center, and the data is copied to the hard drive and securely moved to the data center in Azure in that region and then uploaded. That's a long process. It takes more than 15 days. But those are the options we have for aging data centers. And that presents a challenge to move critical systems. So most critical systems which are 24 bar 7 with high volume and have very sensitive data probably will stay back in the on-premise environment. They may not move to the cloud. The second biggest challenge we have is legacy software and hardware systems. Right? When you have legacy software or old versions of SQL Server, Oracle, or say Sybase IQ 16.0, which is a legacy database system, how do we move that to the to SQL Server, right? Then or to Oracle. Then we need to use ELT tools like SnapLogic or Informatica or SSIS or Azure Data Factory to move such legacy softwares to the cloud. And last, the ETL processes. All ETL processes which move data across the platform, right? They do transformation of data, they load analytical data to data warehouse and from data warehouse to the data mart. So they connect to the transactional system, process the data, and then move it to the data warehouse. These ETL processes needs to be updated to meet the re-platform requirements. So, and these ETL processes, say for a retail royalty program like Shell or someone, they may have more than 600 ETL jobs. So how do we update that? Those are the technical challenges which increase the timelines for migrations, right? So these are three primary factors which increase timelines and pose technical challenges to data migration architects like me when we solution for our clients. Last but least, the case study. I don't know how much time we have. I'll quickly finish it in 5 minutes if I can. So this was one application we were moving for a major telecom giant in US. He had two application servers, and in one of the application servers, he had 6 websites running on it. And then he had SQL Server, three SQLs, one SQL Server database which was connecting to the Oracle to an Oracle database and other SQL databases. So this was the architecture we got from the application owner or the client, and the whole system was a web tier application and database running on SQL Server. The challenge we faced in this architecture was we had to move it to cloud, and the jobs which were running from link server connection, we call it link server, which connects to Oracle, used to run as a SQL agent job every 15 minutes and used to go load 1 million records, right? And the application owner wanted this to move uh, to to a PaaS service in SQL. Right now, the PaaS service in Azure or RDS doesn't support this link server connection. So we had to propose two alternative architecture to the client team or the client architect. So in one, we said we would provision Azure Data Factory, which is a extract, transform, load tool, which is a PaaS service, which will run a virtual machine with integrated runtime self-hosted software running on a virtual machine. And this will connect to your on-premise Oracle databases and SQL Server and bring the data to SQL managed instance. Yes, this solution was offered to him, though this solution is expensive because you need an additional virtual machine which will run the integration software, which will pull in data from the on-premise. But this was the solution you could have, right? Since managed instance or the PaaS service does not support direct connection to other RDBMS currently. This is the same in case of AWS or GCP with SQL Server as a platform. And then the second option we chose is the same option, but we chose to put the virtual machine near the on-premise environment, which is much similar. Here, the virtual machine is in the cloud. The second architecture, we thought we'll keep it in near the data store or the OLTP system in on-premise so that the data latency is low. And from here, we will use Azure ADF data pipelines to copy data into the managed instance. This is the same architecture but a different option where we keep the integration service to inside the on-premise world. And the third option was use the SSIS ETL package, which is a Microsoft enterprise ETL tool like Informatica on a virtual machine directly, and then hit the on-premise environment and then push the data to the Azure SQL managed database here. All these options were expensive for the client, and then expensive in terms of he needed an additional virtual machine and an additional server on the cloud, right? In both these architecture, you need a virtual machine either in the on-premise or in the cloud to do this. And also he needed to pay for using SSIS virtual machine licenses. So the client, who was a .NET developer, came up with his own solution, which was tricky. And he said he will use Azure Functions instead of using a virtual machine, which is a PaaS service, which is less expensive. And he will connect to the data store and push the data in because he was familiar with .NET technology. Usually Azure Functions are good for event-driven transactions, like if you want a promotion that is happening on a transaction system. Say Big Bazaar does a transaction system or a promotion on Wednesday. I offer you 50% less on vegetables. That's a promotion campaign which happens on Wednesday. Then this campaign will create a trigger through the event function. The Azure function will capture the trigger and push the data. So that is where that can be applied. But for this scenario where they are doing batch processing, we do not even recommend Azure Functions. But just for the cost perspective, for batch processing of what he had in his application tier here, he still chose Azure Functions over using Azure Data Factory or SQL Server integration services. So this is about the case study. I'll open the floor for Q&A. I don't know how your online tool does Q&A. So I'll stop here, Sitaraman, and I'll open the floor for questions if any.
Fine, sir. Okay.
So how do I help? Where do I go to see the questions posted?
Yeah, you can see that at the right corner you will have comment box here.
Here?
Yeah, on the screen itself at the right side you will have a comment box.
This one, right? Okay.
So students can post if you have any questions.
Yep. So students who are coming from electronics background, I am an electronics engineer. I ended up as a database architect. So it's a good career path for even electronic guys. Though you're not dealing with electronics, you would prefer to do something else. But if you want a role like this in the industry, it's still open for electronic students as well. I learned it on the ground as a developer, as a DBA, as a data modeler. So I would encourage students for this path as well. And people who have good mathematical skills, like you do Sudoku or you're interested in puzzle solving or you do crosswords at home, or you're interested in playing chess, then this field of data modeling or data migration or analytical platforms which you'll use in your career, it's a good field for you, irrespective of your background in electronics. So I would encourage students, if they're interested in this career path, it's a good career path. I don't see any
comment. If you have any
comment.
doubt, please you can ask directly to Sir Priyanka.
Yeah, I'll pause. Yeah.
Priyanka, may I audible?
Yes, sir.
Yeah, if you have any queries or doubts, please feel free to ask.
No, sir, I don't have any doubts, sir.
So I would think that everybody understood or nobody understood. Either one of this is true.
So it's very understandable, sir. So it's very easy to understand. So we understand everything, sir. It's a very nice topic to learn, sir.
Good. See, there are also certification in this career track from Microsoft. It's called DP203. If you go to the Microsoft website, they give you sandboxes to do this practice also. Okay. If you have a credit card, you will be charged 1 rupee for an Azure free subscription, and you can try playing with it and working on it. So, also there are, I think, academic version subscriptions also available in Azure, AWS, and GCP, which you can use. I think that's all I have for you guys. I need to go. If you have any questions, I'll hold for 2 to 3 minutes, or we can wind up the session.
Dear students, any questions, please? You can use the command box for asking.
So we are good, Sitaraman. I think we can close.
Yeah, fine.
Nobody.
Just a minute, sir. Priyanka, you
Yeah.
can give vote of thanks.
Yes, sir.
Yeah, fine.
Now I would like to present the vote of thanks. It's a matter of pride for me that I get a chance to thank everyone present here. First, we should thank our honorable chairman, beloved vice chairman, our dynamic principal sir, and respectful HOD sir for arranging this kind of webinar for learning new innovative ideas. And last but not least, I should thank our wonderful chief guest and presenter, Mr. Satish sir, for sharing his knowledge and ideas and upcoming events in database. During this pandemic and the new normal time, we couldn't grab any industry events. We couldn't learn. We didn't get a chance to learn everything. So we could grab this wonderful opportunity for learning a new and upcoming events in database to brush up our knowledge. Thank you, everybody. And in addition to that, I should add that my fellow friends who joined this webinar and make this wonderful event. Thank you, sir. Thank you, everybody, for joining this.
Sir, thank you so much, sir. Sunil sir, thank you so much
Welcome.
for your
Take
valuable
care.
presentation.
என்னடி தண்ணி
Have a
வச்சு
good day.
தப்பு தப்பு தப்பு